Hi guys, welcome to the straight to the point reviews. In this video I will show you how you can hook up the 5-pin single phase motor to the power and to show you theoretically what is going inside in order for you to understand. I'm not an electrician, I am an engineer, but I want to learn new things every day, so I hope I can help someone to be as simple as possible and explain step by step how you can identify the wires and how to connect it. Let's begin. Here I will show you how everything is wired up inside of the motor. So we have one common wire leading to the both circuits. This is a high speed circuit and this is low speed circuit. The high speed circuit is different because it has auxiliary winding, which is much thinner wire and more windings, and main, which thick wire, comparing to the low speed circuit that doesn't have auxiliary. Next, on here I show you simply divided circuits. So as you can see, this one is low and this one is high. Now I will show you how to find the common wire, in this diagram the wire number 5, so we can proceed to find out. First step, get a piece of paper, draw the connector. 1, 2, 3 pins bottom, 2 pins on the top. Why? When you turn motor sideways, now you can write down each wire corresponds to each pin. So 1, 2, 3 was the bottom. Let's write it down. First one is red, second one is white, and third one is blue. The first one on top is yellow, second one is black. When you bring motor to the testing position, as soon as you see the connector, now you know each pin is which wire. That is the reason. Finding a common wire is very easy. All you need to have is one multimeter set on continuity. It is this sign over here. So every time we touch the probes, it will make a sound. You place it on any pin that you like, and as soon as it stops beeping, you know it's not connected to the all 5 pins. This one is connected, this one is connected, this one is not, so it's not this one. Try the second one. This one is connected, this one is connected, this one is connected, and this one is connected, which means that this wire here is common. Just I was lucky for a second shot to find out. Let's try others. So third one, connected, connected, disconnected. Fourth one, not connected. Fifth one, not connected. So we know that this wire has contacts with other 4 wires. Which color is it? White color. So white color is common wire. We said that our high speed step we do now is now when we find out that the white wire is common wire. On both simplify diagrams, we will mark it as white. So we know that white wire is common wire. And in this main circuit, it will be number 5. Each circuit will have auxiliary and main winding. And first, we are going to try to find and divide which is a high and which is the low circuit, and which wires corresponds to low and which wires correspond to high. Here is our high speed diagram, and I made a simple female connector which goes to the common wire, in this case white. I hook up the alligator clip to the probes of the multimeter, so it's easier for me to show you guys. So we need to hook up our multimeters to the resistance, which is this sign over here, auto range, and now we can measure the impedance between each wires. So one probe is connected to the, again, white or common, and second one I will connect to the blue wire. And let's see, 20 ohms. Now what we need to do is to write it down. So 20 ohms, and white plus blue. Like this, white plus blue, 20 ohms. Next we measure the white and red, 48.2. Here we write down white plus red, 48.2 ohms. And now we will measure between red and blue, this one and this one, and we can see that impedance or resistance is 67.8. We write it down, 67.8, and we have our all readings, so 67.8. And in this test we can see that the white plus blue, if we add with white plus red, we actually get this number, which means again then this wire is correct. And now when we find out that we have lower impedance, which is white plus blue, is our main winding, because our common winding, because of the thin wire, it has higher resistance, and that's why its value is more, it's 48.2. So we find out that red wire is our main winding and our blue wire is our auxiliary winding, and we will mark it as well. Here we mark it that our red, which has higher impedance, 48.2, and our blue, which has a lower impedance of 20 ohms, and all together is equal as this both. Now here is our low speed circuit. We will measure the impedance or resistance between the white or common wire and one of these two windings, and that will be our yellow, which is first here, and black over here. So first one, we will measure white and black. So white is connected and black is this one over here. 58.8, we will write it down, 58.8. So here white plus black is 58.8, and now we will measure the white and yellow, which is the first over here, and write down 58.2. As you can see, white plus yellow is 58.2, and now we'll measure yellow plus black. So I need to swap this one to the black one, and now we will touch the yellow and check the resistance, 80.2. So yellow plus black is 80.2. So here you can see that this resistance, which is added with this resistance, this one and this one, is not sum of this. So 58.2 plus 58.8 is not 80, because of this winding which is added to reduce the speed of the motor. And now we can mark these windings as yellow or black, like so. Yellow and black, doesn't even matter which one is what, because it will not make a difference. Here, as you can compare the resistance between, for example, white plus blue is 20 and here white plus red is 48, you can see that is way smaller value than comparing to the low speed winding, which is, for example, 59 and 57. So this is how you can separate the circuits with high and low. Okay, so we now know that yellow and black is low speed, and red and blue is for high speed, and common wire is white. Now we can try to connect it and see how it will work. Okay, here is our high speed wiring diagram. Let's go step by step so it will be very easy to understand. We have our common, or what we write down as white wire, is hooked up to the hot wire. So let's do it. So our hot wire, in this case brown, it's hooked up to the common wire pin, which is white. Okay. The next what we need to do is to hook up the capacitor to the pin number 3 and 4, which is red and blue. So here is our capacitor. It has two wires that I lead through here. So we hook up with red and blue. So this pin and this pin, which is blue. Okay, so what we missed is where to connect the neutral wire. And on diagram we see that the neutral wire connects to the main windings. And how to know which one? We already write it. The main windings is blue. So we need to connect the neutral to the one part of the capacitor and main windings, which is blue. So blue is main windings, so we need to hook up the neutral to the capacitor. And I made the wire like this, so make it possible, like this, the vago, and like this. That's it. So neutral goes to the capacitor, and also blue, which is main winding, and other side of the capacitors goes to the starting or auxiliary windings on the motor, and our hot wire is going to the common wire of the motor. And now we can plug in and hopefully we can see the rotation. Very simple. Here is shown how to connect the low speed circuit. So it's this one over here. We said that on low circuit we have yellow and black wire and common wire is white. So on the common wire we hook up the hot wire, which is this one. So again it goes to the middle, or as we saw here on the connector, the white wire. And the capacitor goes between 1 and 2, which is yellow and black. So we will do it. We have our capacitor, 2 wires. Where is red, when is yellow? Here is black, the second here, and yellow is this one over here. And what's left is only one wire, which is neutral. And how we will connect neutral is to the either side of the capacitor, either number 2, either number 1, and this will determine the rotation. So again, vago connections make it easy. Let's hook it first on the blue side of the capacitor, so neutral goes to blue, and let's hook up to the power and see the rotation. So now it's going counterclockwise, and what we learn here is we can also hook it to the another side of the capacitor, to the neutral one, and it will go in different direction, which should be clockwise. So let's take a look here. It's disconnected the neutral wire here and connect it to the other side of the capacitor like this, and now we should have a clockwise rotation, and that's correct. Now it's rotating low speed and clockwise. Okay, I hope you learned everything you need to know about 5-pin motor. Thank you for watching and goodbye.